Hello everyone, this is the North American Math Contest Go Go Go. This week we are going to work on a problem called Night Hop. So it is an 8x8 chessboard. And you are required to find how many night hops it needs from the starting location to the ending location. For example, if your point is at here at starting point and this as the ending point, then your shortest path is 1 because you can get the night hop, you can get the final destination with only 1 night hop. So this is how the night hop looks like. Your problem will read the starting location of the knight and output the smallest numbers, jumps, or moves needed to arrive at a location specified in the second input. The program will read 4 integers. Each integer is in the range of 1 to 8. The first integer represents the starting position of the knight, and the second to represent the final position. And then the output is the minimum number of the moves. And remember, the knight is not allowed to move off the board. Let's start doing the problem. Here is the correct code for this. So this code is using the depth first search. Now let's talk about the code. The code basically has 2 parts. The first part is depth first search code, which can help you search the shortest path, and this is the void main, which initializes important values. So this is the ij does not mean anything. It is only used once for the initialization of the grid A. The start x, start y refers to the initial coordinate. Using scanner, we scan it out. And then the PQ refers to the endpoint. The bookmark is that the initial point as a place that has been walked past. So if you walk past, during the attempt, if you walk past a point, then the bookmark will set the point as 1, which means that this place has been walked past. So what will happen if we don't set it? If we don't set it, then the code will be, then you might lead to a result like this. So let's assume this. This is the destination and this is the starting point. If you don't set the bookmark, you might end up going like this. Here, jump to here, back to here, jump to here, back to here, jump to here, back to here, jump to here. Endless loop. And then what will happen? The code will crash. So that's why the bookmark is important. DFS. So the purpose of this is to activate the depth first search method here. And the system.out.println refers to the shortest path. Now let's go on the depth first search. So the next array, this one, refers to the 8 types of methods it can work, steps it can work. So for example, 1, 2 refers to jumping from the initial point to here. 8 ways of night hop jump. For example, this refers to jumping like this. Then we set some initial, then we set 3 variables, tx, ty, and k, which will be discussed later. So K, the purpose of K is also only designated for for loop. It is only used once in the code. So let's see, if x is equal to p and y is equal to q. So if it reaches the destination, then we are going to get into the next calculation. If step is less than mean, so if the step you reach is less than the minimum step that you have previously calculated. So the mean is used to store the shortest path. Return, then return. You go back. Mean is equal to step. Now it is the calculation of this. So that's why I say that the depth first search is a bit related to recursion, because it will also run recursively until you reach a result. So the tx is the x coordinate that adds the walk path. So it is the tx coordinate after walking effect, after the effect of next. And similarly, this is also the y coordinate after the effect of the next array. So this part we check whether it is out of bound. If it is out of bound, then we might need to go back to the previous step. Then it's this one. So this means that if the step you walk, if you get to a step that does not have been walked before, then you will bookmark it, and then you will try next step. Okay, so if you get to step A, then this step will allow you to bookmark A, then you try step B. Then you go up and you try step B and goes to here. If step B is also has not been worked before, then mark step B and get to step C. So it works so on so forth until you reach the destination point. Okay, so after you finish the attempt, which is you finish this set of attempt, you set the bookmark as 0, which means that you have not walked past it. So the code is generally like this. If you find the smallest value, then you go return, you go back to the here, and then you type out the shortest path, which is mean. So this is how the code works. Let's try running the code to see whether it works or not. Okay, that's a small error. Don't care about that.